Hi guys, we'll be doing 5.11 solving optimization problems. It's the same thing as basically 5.10, but this one you can either use a calculator or it's just more problems. So here we'll just be doing one part A and part B. But let's get into the problem. A particle is traveling along the x-axis and its position from the origin can be modeled by x to t. X's function of t equals to negative 2 over 3 t cubed plus t squared plus 12t plus 1, where x is meters and that t is minutes on the interval. At what time during the interval 0 is less than or equal to t less than or equal to 4 is the particle furthest to the left. So that's very important. So for here, so it's asking at what time t during the interval. I'm gonna say, and the particle is furthest to the left, I'm basically gonna say like since this is giving us position and this is the first, like the f of x, the function, the regular function, we have to do a velocity function, which is taking the derivative of the first x of t, which is the first function of position, because velocity is first derivative of position. So first we take that, because it's asking where it's going to be, like, and then like how fast, so basically time. This will be just like at what time, but like it's still asking like where is it going to be at that time, like the average speed, not speed, but like, oh well, it definitely speed, like instantaneous, like where is it going to be at that point. And you can't use a position graph, because you need to know, like, we need to get the critical points, and to get the critical points of the graph, which is the critical points of the function, you have to derive it. So yeah, it'd be vt equals, so just like derive this, be negative 2t plus 2t plus 12, and so I'll just take it out. Oh, that's supposed to be a minus, sorry. It's be negative 2 in parentheses t minus 3, t plus 2 equals 0, t equals 3, and t equals negative 2. So critical points. But you gotta look at the interval. So for one critical, we're only going to be using one critical point, which is 3. And basically this is like the candidate's test in a way, but you can kind of see it as a candidate's test, because we'll be trying to find out where the placement of the particles are. But for what I was saying before, you can't use negative 2 as one of the critical points, because that's not in the interval. So what we'll be using is 0, 3, and 4. And we just plug in into our equation. So I'm going to plug in these points into our equation and get the solutions, and I'll be right back. Okay, so what I did for the points that's on the interval, you plug the points back into the position, because that's what we're basically asking. It's the position of where the particle is. We only used the velocity type equation to find the critical points, because it's basically like the candidates, like the Stromos test from previous videos. But since we're asking position, we go back to the position equation, which was this one. And I got, for at 0 it would be 1, at 3 it would be 28, and 4 it would be 22.333. But it's asking furthest to the left, so that means it's either decreasing are just moving to the left. So it'll be the far negative, you know, like this far side. So it'll be 0, 3, 4, you know, 28. That'll be 1, and that'll be like 22. So which one's furthest to the left? And that'll be t equals 0. Okay, for the next one, we're saying on the same interval, what is the particle's maximum speed? So the maximum speed, that means we have to get the second derivative, which would be acceleration. And we have to get the derivative of that, of the velocity, because this is second prime, you know, well, f prime of 2. So that'll be -4, t plus 2, and there you have it. And we're just going to solve for t. So set it equal to 0. So it'll be -4t plus 2, and that'll be -4t equals to -2 over -4, -4. So t equals 1/2. And that is what we're going to be using to decipher, because you got to see if it will change or not, or depending on the acceleration type equation, you got to see, we're using this point to see if it's changing. I basically think of it as like, like I said before, like an inflection point. Inflection points is when your f double prime sign changes. So like, since acceleration will be here, since it's talking about like the maximum speed, we got to see which one reaches to the highest speed based off which one is being changed at each point. So here we're going to use our same interval, so it'd be x double prime of t. I just like to put that in rhyme and use this double prime. 0, 1/2, and 4. So here we will be plugging in our equation, into the velocity, because velocity is what the speed is, basically. We just need to see this to see which one will be changed, the sign changes, you know? So I'll be back and I'll plug my points into the velocity function. So I got these values for my points, and it's saying on the same interval, what is the particle's maximum speed? So for here, we got to see which one is greatest, which will be at x double prime of 1/2, the particle's maximum, the camera, trying to write at the same time, maximum speed is 12.5 meters per second. Yeah. Oh, make sure to put your unit at the end, because that's very important. And yeah, that'll be all. Bye, guys.